So the trend in atomic radius in the periodic table has to do with this. As you go from right to left in the periodic table, we see that the atomic radius increases. As you go down the group in a periodic table, remember, this row is called a period, this column is called a group. As you go down a group in the periodic table, the atomic radius increases. This increase in the atomic radius down a group is due to the fact that you have increasing energy levels. You have increasing principal quantum number. The reasoning why the increase of atomic radius goes this way across a period in the periodic table has to do with the fact that you're getting more valence and outer electrons here towards the non-metallic side in the periodic table. You have electrons that tend to cling on to their electrons more. So in this particular problem, it's asking for arranging the groups based on these elements according to their atomic radius. So we have them highlighted here, and this pretty much follows a very simple trend here. So sodium with a +1 valence electron, that is to say this is sodium, not sodium +1, but sodium by itself has that valence electron wanting to go away, wanting to be sacrificed so that it can be a nearest noble gas. That's going to be larger. So the largest one here is going to be sodium. Magnesium +2, that has 2 valence electrons it can give, so that's going to be the second largest. And then Al, and this just pretty much follows the same trend here because the trend is you go increasing from right to left. So magnesium is going to be greater than Al, which is going to be greater than phosphorus, which is going to be greater than chlorine. So anything over here is very small. They really, really tug onto their electrons. They don't want to give them away. These want to give away their outer electrons, so they tend to be very, very large. Now coming to the aspect of the smallest atom in group 7A, coming to the smallest atom in group 7A, we see here, again, as you look down the halogens, as you go down the group, you're getting to higher and higher and higher principal quantum number. So this would be n equals 2, n equals 3, n equals 4, n equals 5. So obviously the smallest atom here will be fluorine. Okay, we're not talking about ions, we're talking about atoms. So the smallest element, the smallest atom in the halogens, which are group 7A, is fluorine. The largest atom in group 4A, if we want to continue this trend, you're going to look for the largest going down in group 4A, so that's probably going to be one of these, maybe lead or tin, or this one I don't know much about, but probably lead would be the largest element in group 4A. Again, the trend is as you go down a group, the larger the size of the atom is. We're not talking about the ionic radius now, we're talking about the size of the atom, the atomic radius.